Okay, hi everybody. So in this video here, we're going to take a look at powers of binomials. So we're going to just expand a few binomials here. Now, I'm going to follow a very specific pattern as I do this. And so for this first question here, what I'm going to do might seem a little bit over the top here, but I got a reason for it. I want to expand on this later on here, and I'm going to show you how this works and then I'll compare it to what you probably would do with a question like this. So to start off with, what I've got here is 3x minus 1 squared. Now, because the exponent is 2, what I'm going to do here is I'm going to start off with writing down parts of my coefficient. So I know it's going to be 2 choose 0, 2 choose 1, and 2 choose 2. I know there's going to be 3 terms because I'm going to list my combinations off from 0 up to the exponent. And then I know it's going to be the first term in my binomial squared, first term of my binomial to the 1, first term of my binomial to the 0. And then the second term to the 0, second term raised to the power of 1, and second term raised to the power of 2. And now I evaluate. 2 choose 0 is 1. This is going to become 9x squared, and negative 1 to the 0 is just going to be positive 1. This will be 2 multiplied by 3x multiplied by negative 1. And then this will be, again, 1. 3x to the 0 is just going to be 1, and then negative 2 squared is also going to be 1. And so when I evaluate, I will get 9x squared minus 6x plus 1. Awesome. Now, you might look at that and say, hello, could have done that a lot quicker. And the answer is, yes, you could have. If you had done 3x minus 1 multiplied by 3x minus 1 and just distributed that out here, and some of you are going to be so familiar with the pattern of squaring that this isn't even an issue here. You know this is going to be 9x squared minus 3x plus 1, which becomes 9x squared minus 6x plus 1. So I know I'm getting the exact same thing here. The point is, though, that works really, really well if you've got it squared. And some of you might even be really quick when it comes to cubing something, but as soon as it becomes the fourth power, fifth power, sixth, and so on, expanding like that becomes a much, much slower process. And so we're looking for a way of kind of sidestepping that process. And what I just did initially is a good way to do that. Anyway, again, I know that there are a couple of ways to do that, and we're going to take a look at some more examples in some other videos.